We're asked to find extrema by using the second derivative test. The first thing we're given is a function, which is great and going to be super useful, but then we need to find, first we need to find our critical points, and then we need to plug those critical points into the second derivative to determine whether those critical points are maxima or minima. And also we need to see if they're absolute or relative. So let's write out our first step is find critical points. And how do we find critical points? Well, we find when the first derivative equals 0. F prime of x equals 0. Or f prime of x does not exist. So let's see. First, and in this case, this is g. So let's use g from now on. G prime of x equals the derivative of 2 cosine x, which is negative 2 sine x, because cosine's derivative is negative sine. Negative 2 sine x plus the derivative of x is 1, so plus 1. Now we need to see, is this ever undefined? No. Every x value works for sine, so we're good there. But is it ever equal to 0? 0 equals negative 2 sine x plus 1. I'm going to subtract 1 from both sides. Negative 1 equals negative 2 sine x. Divided by negative 2, so 1/2 equals sine x. This is where our handy-dandy unit circle always comes in. We want to figure out when is sine of x equal to 1, or when is sine of theta equal to 1 if you're thinking about the angles on the unit circle. I am going to just draw a rudimentary unit circle right here. And when is sine of x equal to 1/2? At these points. And so I know that this is pi over 6, and this is 5 pi over 6. The coordinates here being root 3 over 2, comma 1/2, and here being negative root 3 over 2, 1/2. Since we're looking at the y's, right, when we're trying to find sine, I know that pi over 6 and 5 pi over 6 are my x values. So I'm going to write that down. X equals pi over 6 or 5 pi over 6. Alright, so we have our 2 critical points. That's great. Now what we need to do is we need to determine whether or not these are maxima or minima by applying the second derivative test. I'm going to do this in yellow. 2. Plug CP's into, I'm going to write G double prime here, but it's generally just whatever the second derivative is. So let's find that first. G double prime of x is negative 2 sine x will become negative 2 cosine x. And then 1's derivative is 0. So there it is. G double prime is negative 2 cosine x. We don't set this equal to 0. We have to plug in our critical points to figure out is it a maximum or minimum based on the concavity at that point. So let's do our first one. G double prime of pi over 6 is negative 2 cosine of pi over 6. It's nice that we had our unit circle here because I know cosine of pi over 6 is root 3 over 2. So this will equal negative 2 times positive root 3 over 2. And so this gives us negative root 3, which is less than 0. That tells us, since the second derivative is less than 0, we know that it's going to be concave down there. So we can imagine there's our point. If it's concave down and we have an extrema there, is that going to be a maximum or minimum? It's going to be a maximum because it's at the top. We'll come back to that when we're writing out our reasoning. We want to do G double prime of 5 pi over 6, which is equal to negative 2 cosine of 5 pi over 6. Again, great that we already found it because we see cosine of 5 pi over 6 is negative root 3 over 2. So this is negative 2 times negative root 3 over 2, which we'll get, because negative times negative, that'll give us positive root 3, which is greater than 0. So we have a situation like this, where it's concave up. And so that tells us we have a minimum. So our final answer, I'm going to write this in blue, is that we have a relative min at x equals pi over 6, because f prime of pi over 6 equals 0, and f double prime of pi over 6 is less than 0. So that's our reasoning there. And then our next one is we have a relative max at x equals 5 pi over 6 because f prime of 5 pi over 6 equals 0 and f double prime of 5 pi over 6 is greater than 0. Oh dear, I switched these up. The first one should say this is a relative max, and the second one should say this is a relative minimum. My apologies. So there we go. Our reasoning is right. Answers are right now. Here we go. Relative max at pi over 6 and relative min at 5 pi over 6.